So we're beginning our chapter on surface area. First thing to discuss is what surface area means and what lateral area means. Surface area means that we're getting the area of every surface on a three-dimensional object and adding them together. The total area of all surfaces. Lateral area means we do not include the bases. So for clarity purposes on this one I shaded the bases, but normally it would be up to you to identify where the bases are on a three-dimensional figure. So I shaded the two bases here, the two congruent parallel surfaces that are connected by parallelograms. These are the bases of the prism. So if I was getting the lateral area, I would not include the area of these two pentagons. It would just be the 5 rectangles going around. Some books call lateral area lateral surface area. I think the MCAS does that. Other books, like our book and I, usually just call it lateral area. But the key thing is, if you see the word lateral in there, it means you're only doing the lateral faces, you're not including the bases. So lateral area will always be less than surface area, because surface area, you're adding the areas of the bases. So one way to get the lateral area of a prism is just to get the area of all the lateral faces and add them up. But if it's a right prism, there's a formula. We're going to come up with that formula right now. Remember, a right prism means that segments connecting the top base to the bottom base, or one base to the other, these edges are perpendicular to the bases, as opposed to an oblique prism where one base would not be directly above or below the other base, so the edges that connect them do not form right angles. So one of those slanted sorts of prisms would be called an oblique prism, and for those you'd have to do the surfaces individually. But if it's a right prism, which is what we're going to be dealing with, there is a formula. And here's the idea. Suppose this length was A, this is B, from here to here, this is C, this is D, this is E, and the distance between the bases is the height, H. If we wanted the lateral area of this prism, that would be the area of the 5 rectangles, so that would look like this. Let me zoom out a little bit. So the lateral area of the prism would be the area of this rectangle, which is A times H, plus the area of this rectangle, B times H, plus the area of this rectangle, C times H. This rectangle has an area of D times H, and that back rectangle is E times H. So a little bit of algebra, factor out the common factor of H with the distributive property, and we get this line, H times A plus B plus C plus D plus E. But A plus B plus C plus D plus E is meaningful when we look at that picture. If I add up these 5 lengths, what I'm really getting is the perimeter of the base. So let's replace all that with P. So H times P, or P times H, is the formula for the lateral area of a right prism. It's important to remember that that P specifically is the perimeter of the base. And we'll practice that on 4 or 5 examples coming up. It's important to remember the height is not the height of the base, it's the height of the prism. It's the distance between the bases. So if I wanted to get the surface area of a right prism, it would be all of this, which is all the lateral surfaces, plus 2 times the area of the base, because all prisms, of course, have 2 bases. So we'd have to get the area of one of them and multiply by 2 and add that to the lateral area. So these are the 2 formulas for prisms. Let's try some examples. So maybe you can get a look at this, pause the video, give this a shot, and I'll be right back with my solution. So let's see. The best tip I can give you is to draw the base by itself when you're working with three-dimensional figures. And on this one, the base is not that bottom rectangle. This is not the base. Because remember, all prisms have two congruent parallel bases connected by parallelograms. There is not a congruent surface to this one parallel to it. The two congruent surfaces are the two triangles. These are the congruent parallel surfaces connected by parallelograms. So the triangles are the bases. The height of the prism is the distance between the bases. That's here. So here's my solution. I want you to notice the first thing I did was I drew the base by itself. I drew this right triangle, and we were only given the two legs, but since it was a right triangle, the Pythagorean theorem tells me the third one has to be 15. 9 squared plus 12 squared is 15 squared. That's a triple. So the lateral area of the prism is the perimeter of this base, which is 36 when you add them up, times the height of the prism, which is the distance between the bases, 18. Perimeter of base times height, 648 centimeters squared. Even if you didn't know this formula, you could still get the lateral area. You would just have to get the area of the three white rectangles up here and add them up. So for instance, the rectangle on the back is 18 times 9, 162, I think. The bottom rectangle is 18 times 12, and this front slanted rectangle is 18 times 15. And if you add those together, you'll get 648. Formula just makes it a little faster. The surface area of the prism would look like this. Now, if we already knew the lateral area, then to get the surface area, we just have to add the area of this triangle twice, because there's two of them. I wrote this out as if I hadn't already done this work, because usually you're asked to find one or the other, not both. So if I was asked to find the surface area of the prism, I would write perimeter of base times height plus 2 times area of base. And in this case, since the base is this triangle, I replaced the base formula with the area of a triangle formula. Half base height, height of the triangle, not the height of the prism. These are two different heights. This height is 18, the distance between the bases, but this represents the height of the triangle, which is 9. So perimeter 36, height 18, times 2 times half times the base of the triangle is 12, height of the triangle is 9. I did some simplifying, but the final answer is 756 centimeters squared. All right, here's the second one. So when you are asked to find the lateral area of a rectangular prism, a right rectangular prism, there can be more than one right answer, depending which surfaces you're considering to be the bases. On this one, I shaded the top and bottom because I looked at those as my bases, the congruent parallel surfaces that are connected by parallelograms. But you could also correctly say that the front and the back are the bases, and there are 4 parallelograms going around connecting them. You could also say that this rectangle and this rectangle, the left and the right surfaces, are the bases. And you'd get 3 different answers depending which ones you were looking at. So that's fine for lateral area of right rectangular prisms. You can get 3 different answers. Surface area, we should all get the same answer because we're essentially getting the area of all 6 rectangles and adding them up. So when you try this one, if you want to do it the way I was looking at it and compare answers, consider the top and bottom to be the bases. So why don't you hit pause, get the lateral area and surface area. Alright, so here's my lateral area. Perimeter of base times height. So the perimeter of this rectangle is 9 plus 2 plus 9 plus 2, 22. The height of the prism is the distance between the bases, which is the 5. So 22 times 5, 110 inches squared. How about surface area? A little more work because we have to get the extra 2 bases. Perimeter of base times height plus 2 times area of base. In this case, the base is a rectangle, so I did base times height, meaning the base of the rectangle times the height of the rectangle, not the height of the prism. If I'm getting the area of the base, which is that rectangle, I need to do 9 times 2. That's what I'm doing down here. So there's perimeter of base times height plus 2 rectangles. Each rectangle is 9 by 2. If you multiply that out, add them together, 146 inches squared. All right, here's the third one. A little more challenging, but certainly within your grasp. What is the lateral area and surface area of this triangular right prism? Let's round off to the nearest tenths. Round off to the nearest tenths. All right, so first thing is, I'm hoping you remembered to draw a base by itself. In this case, hopefully you recognize that the triangles have to be the bases. So I started by drawing just one of the triangles, and that would look like this. Get this in frame here. So I started by drawing one of the triangles. And I knew the sides were 5, 5, 4. I knew I was going to have to get the area of the base at some point. So I thought about how do I get the area of that triangle. And there were a couple ways we could do it. Could do Heron's formula from a previous video. Or we could do 1/2 base height, which is what I chose to do. So the base was 4. I drew the height, creating 2 congruent right triangles because of the hypotenuse leg matching the hypotenuse leg. These triangles are congruent, so these lengths are each 2. Pythagorean theorem, height squared plus 2 squared equals 5 squared, gives me root 21 for the height. So that's where that came from, Pythagorean theorem. So let's take a look at the 2 answers down below here. The lateral area of the prism is the perimeter of this base, 5 plus 5 plus 4, 14, times the height of the prism, distance between the bases, 12. 14 times 12 is 168 centimeters squared. Surface area would be perimeter base times height plus 2 times area base. And again, I replaced my base formula with whatever the appropriate formula is. In this case, 1/2 base height for the height of the triangle and the base of the triangle. 1/2 base height is going to get me the area of that triangle. Of course, I'm multiplying by 2 because there are 2 triangles that I'm adding on. So perimeter of base times height plus 2 times 1/2 base height. And I did some simplifying, but to the nearest tenth it would be 186.3 centimeters squared. All right, 2 more to go. Number 4. Let you get a good look at this one. Question is, what is the lateral area and what is the surface area, each to the nearest tenths? Okay, let's see how you did. Did you remember to draw a base by itself? In this case, a base would be one of the trapezoids, one of the 2 congruent parallel surfaces on the prism. So I drew one of the trapezoids by myself. I'll show you in a moment. I knew that this was 7, and I also knew since this was 4, that this was 4. So here's my trapezoid by itself. Now, where did all these extra measurements come from? Because in the picture, all we had were some angle measurements and the 4 and the 7. But I know I need to get the perimeter of the base. I'm going to have to get the height of the trapezoid. So it seemed reasonable to draw a perpendicular segment here to create a right triangle. Not just a right triangle, but it would form a 45, 45, 90 if I add a perpendicular segment here. That's helpful. So, once I drew that, I recognized that since this is 4, the opposite side of that little rectangle there would be 4. This is 4. 7 minus 4 is 3. Since it's a 45, 45, 90, 3 root 2. And since the height here is 3, the height here would be 3. So I've got all the side lengths of my base now, and I've got the height of my base now, and I can get to work. I'm going to zoom out a little bit. Here's the rest. Let's see if I can get all of this in one shot for you. That might do it. So, perimeter of base times height. So the perimeter of this base is 7 plus 3 plus 4 plus 3 root 2. So that's 14 plus 3 root 2. Multiply that by the height of the prism. The height of the prism is 10. Now, I did say round off to the nearest tenths, but just to avoid calculator issues, I did distribute that 10 to make it 140 plus 30 root 2. So 184.2 meters squared for lateral area. How about surface area? Surface area means we have to add the areas of the bases. So pH plus 2b. How do I get the area of a base of if it's a trapezoid? Well, this is my trapezoid formula. Half of the height of the trapezoid times base 1 plus base 2. That's from previous videos, or a previous video. So there's the perimeter of the base, the perimeter of the trapezoid times the height, just like before. But now we're adding the two trapezoids. Half of the height times base 1 plus base 2. Remember, on trapezoids, the bases are the parallel sides. And again, I did some simplifying to make this easier to put into my calculator, but any of these lines entered correctly will get you the answer 215.4 meters squared. Okay, one more to go. To the nearest tenths, what is the lateral area and surface area of this regular decagonal right prism? And that's a little bit redundant. Really, if I just say it's a regular decagonal prism, that means that the base is a regular decagon, and if it's a regular prism, it also means it's a right prism. But I'm just being extra clear for you there. So nearest tenths, lateral and surface area. All right, so here's how I did it. I'm going to start with this, and then I'll zoom out and show you the rest. So I started by, I always say draw the base by itself, but as we saw back in the area chapter, there's no need to draw the entire base if it's a regular, anything more than a hexagon. I don't usually draw all of the sides because all of the work tends to come down at the bottom of the figure. So these are the 3 of the 10 sides of the decagon. The other 7, I'm just imagining that they're there. And we know the formula for a regular polygon is half AP. So I need to figure out the apothem of this regular decagon so I can later get its area. So I drew the apothem, I drew the radius, just like in our area chapter. The angle measures, of course, come from 10 minus 2 times 180, and then I divide that by 10 to get each interior angle of a regular decagon measuring 144 degrees. But the radius bisects this angle, so half of 144 is 72. So 1872.90. And I want this apothem. I know the apothem cuts the side in half, so if this is 4, I know this is 2. So I got to use my trigonometry. I wrote a tangent equation. The tangent of 72 is the opposite leg over the adjacent leg. So that's A over 2. And when you cross multiply, the apothem comes out to be 2 times the tangent of 72 degrees. Notice I didn't round that off. I left it just like that, only rounding the final answer. So now that I have all the numbers I need, we can answer the question. Lateral area, perimeter of base times height. The perimeter of the base is just 4 times 10, 40. The height of the prism was the 5. 40 times 5, 200 feet squared. The surface area of the prism is perimeter of base times height plus 2 times the area of the base. So the perimeter again is the 40, 10 times 4. The height of the prism is that 5. And then 2 times the area of the base, so 2 times half AP. And if you're wondering, don't the 2 and the half multiply to make 1? Don't they cancel? Yes, I left them there just to be clear about what each number was on this line, but those do multiply to 1. So the apothem is 2 tangent of 72 degrees. The perimeter is 40, same as it is over here. So 200 plus 80 times the tangent of 72 degrees is 446.2 feet squared to the nearest tenths. All right, so there are 5 examples done for you. I hope this helps.